So I cheated a little bit. Are you going to be mad at me? I hope not. I don't know. I didn't really cheat. What I did was I took a look at the graph with my graphing utility because obviously, we're in the new age. You got to use your graph. And you got to understand what the graph is, but I believe it's also very important to be able to know how to do this algebraically. Make sure you can verify what's in technology, right? Because you can never just assume everything that technology has is always going to be definitive and always correct. We got to make sure we can balance it back by using the rules that we know. So what I want to do is first the problem asks us to find all the real zeros by using P over Q. Now remember, P over Q is going to be our rational zero test. That's going to tell me all of the possible rational zeros. So to do that, I have to take my P and take it over my Q, where P is going to be all the factors. P is going to represent all my factors of my constant, and Q is going to represent all my factors of my leading coefficient. So what I have is P over Q equals plus or minus all the factors of 16, which would be 16 plus or minus 4 plus or minus, let's do 8 first, then do 4, comma, plus or minus 2, comma, plus or minus 1. All over all the factors of 3, which are going to be plus or minus 3, comma, plus or minus 1. Now, to make this even better, what I'm going to do is I'm going to list everything, and then we'll eliminate sums that we don't have at the end. So let's see. Can I start here? All right. So let's do P over Q equals plus or minus 16 over 3 plus or minus 16 over 3 plus or minus 16 over 1, comma, plus or minus 8 over 3, comma, plus or minus 8 over 1, comma, plus or minus 4 over 3, comma, plus or minus 4 over 1, comma, plus or minus 2 over 3, comma, plus or minus 2 over 1, comma, plus or minus 1 over 3, comma, plus or minus 1 over 1. And actually, ladies and gentlemen, when I look back at it, I'm not really seeing any duplicates, zeros, and that's actually pretty good. But what you can notice, ladies and gentlemen, is there is a lot of possible rational zeros here, right? I mean, I already have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So back in the day, you'd have to go and verify and see which ones worked and which ones didn't. Thankfully, we have technology. We have Google, we have graphing calculators. We can just test and take a look at what the graph looks like. However, even if you know what the graph looks like and you can determine where the zeros are, we still want to make sure you can verify it algebraically. So I took a look at the graph, and it looked to me, I used Google. I didn't use my graphing calculator, so I wasn't able to verify in there. But it looked like I had zeros at 4 and 2. It looked like my graph crossed at 4 and 2. So to verify them, what I'm going to do is I'm going to use synthetic division. So I use synthetic division. So I have negative 3, 20, negative 36, positive 16. So I bring down the negative 3. Negative 3 times 2 is negative 6, which gives me a positive 14. Gives me a positive 28. Gives me a negative 8, negative 16, and 0. So therefore, 2 is a 0. Awesome, right? Well, now I want to verify if my 4 was a 0. So I'm going to take my solution, and now I'm going to divide by 4. So I'll just take the previous solution, and I'll see if that can be divided by into 4. So I drop down the negative 3. Negative 3 times 4, negative 12, 2, 8, 0. Awesome, which leaves me with the last factor, which is negative 3x plus 2. And remember, that's a factor, so we can set it equal to 0. And then to solve for that, I'll subtract the 2, and I get, that's a weird 2. Negative 3x equals negative 2. Divide by negative 3. X equals 2/3. So therefore, my zeros of this problem are going to be 2/3, 4, and 2. Done. Thank you. Hope you enjoyed.